finding the slope of a line. So we've now understood that we have lines that can go up, positive, down, negative, horizontal, 0, and vertical, called undefined. So now what we're going to do is we're going to start actually giving actual numbers to indicate how steep these lines or these slopes are. And steepness can change. Steep can be this, getting a little higher, a little bit higher, and then vertical. So what we're going to be talking about is we're going to be giving numbers to the steepness. Now, that comes from a rise and a run. Now, you probably heard about that in school. I remember a little bit of it. But let's go through it again. First off, slope is now going to have its own symbol. And the symbol for slope is going to be an M. That is the symbol for slope. Okay? Now, we talk about rise and run like this. Rise and run. First off, you notice that's a division bar? Well, and it's also, you're also given two numbers. This is a ratio. So you're going to have a number as a numerator, and a numerator is a denominator. Your numerator number is talking about how much this thing goes up. Now, this can be a little tricky for some people. So what I want to do is I want to start with something easy. I want to mark on this first symbol, or let's call this A as example A. I want to put a dot right there. Now, what I want to do is I want to find another dot along this line, moving in this direction, where the line actually crisscrosses right through the middle of two lines. Because those are called whole numbers. If you'll look along the line, I can actually count those. For instance, if I asked you, hey, where is that? You would say, it's actually at the 2 mark. I would say, yes, it is. If I said, where's this one? You would say, it's at the 1, 2, 3, 4 mark. You see, these are whole numbers. Anything that's in between, you see like that, where it's in between two pieces, now you're talking about decimals, and that's going to be harder to calculate. So that's why you're looking for the line where it crosses exactly through the center so that we can count it as a whole number. Okay? So what I'm going to do is I'm first going to start with this dot, and I'm going to find another part of the line where it crosses straight through. And I'm going to say, how about that one? Okay, so do I have 2 dots? Yes. So what I'm going to do now is I'm going to figure out, well, how much up or rise does it take for me to get aligned with the next number or the next point? So you would say, well, from this dot, you have to go up 1, 2. So that means I had to go 2 up. Now I'm at a line where it's at. So my rise is actually the number 2 because I had to go 2 up to be aligned with the next dot. Now I'm going to say, okay, from there, let's pick a nice color. Here we go. How much, if I'm here, how many units do I have to bump over to the right in order to hit it? So if I'm here, I have to go 1 more unit over to the right, and now I'm on top of that next dot. That's called my run. I had to run to the right 1 unit. So my rise is 2, and my run was 1. This is called slope. 2, 1. 2, 1 indicates the pattern that it takes for me to hit the next dot. Now, this one's kind of interesting. Watch this. Let me get a bit of color here. Watch. From this dot, I can go up 2 more and then to the right 1. And guess what? I'm going to be right on the line again in the crosshairs. Watch. 1, 2, and then over to the right 1. Look at that. I'm on the next. Look, I'm right there. Do it again. 1, 2. Look right there. Isn't that interesting? So this is actually my slope. If they said, hey, what is the slope of that line? You would say 2, 1. Now, on the test, you see how we have a 2 and a 1 on, or 2 on top and a 1 on bottom. If you have a 1 as your run, like that, then usually what the slope is given as just 2 divided by 1, which is 2. So they would just say m equals 2. If I see a whole number like this for my slope, I'll know, oh, that means that the run was 1. So it's really 2, 1. So these two things are the same. So if you're looking and you see slope as written as a whole number, the run number, the number on bottom for my ratio, is the number 1. Okay, let's try it again. Look at the next one. Again, the first job is to find a spot on the line where it crisscrosses through the coordinate grid, where it goes right through the center. And it could be anywhere along that line. And I see one right now. I'm going to go ahead and say that. Okay. Now, that's my first point. I want to find another point along the line, and it doesn't even have to be close. For instance, I'm going to say that one way over there. Now, if you said, well, Varen, there was others between, like, for instance, could you have done that one or that one? And the answer is yes, I could have. But it doesn't really matter. Because of the way that this works, my slope is going to come out just exactly fine. So what I want to do first is I want to start with my first, and I call this first, because you want to move from left to right in the direction. It's a very easy way to understand this. So you want to move in a left to right direction when you're going from point to point. So I want to go from the most left to the most right. You don't really want to think about this going backwards, though you could. It's just going to be a little interesting with the way the numbers come out, and you'll have to remember what you're doing. So let's just go from left to right to keep it the easiest to understand. So what I'm going to do is I'm going to count. Now, you'll notice that from this point A, let's call it point A to point B, I don't move up in order to be aligned with it. I actually have to move down, which means I'm going to be a negative number. So my number, let's figure out how much I have to move down to be aligned. So I'm going to erase this, give me some room here. We're going to go ahead and do that. You ready? I have to move down 1, 2, 3 units to be aligned with that next one. You see it? To be aligned with it. So my top number of my ratio of rise and run, my top number, my rise is actually a fall, but it doesn't matter. We can still call it rise, but it was a fall of -3. Now let's figure out that run. Okay, here we go. So from here, how many units to the right do I have to go in order to hit it? Let's find out. 1, 2, 3, 4, 5, 6. So I had to move positive right 6 in order to be there. So my run is 6. Now, they call this, the direction the slope is going, isn't it called negative? It is. Look at the ratio. The ratio is -3, 6. Well, when you write this, you would say the slope equals -3, 6. Now, these ratios, remember, can be simplified. So, which means I can make this look smaller, 3 and 6. I could divide them both by 3 and call this actually slope equals -1/2. Now, when you do that, so remember, I simplified to go from here to here. The negative number, or the negative, always goes with the top number. Always. Because you saw that up here. You had to move down 3 to get to the next, to be aligned with the next dot. Now, you might look at this and say, well, Varen, wait a minute. How come when I did it, I got 3, 6, but you're also saying that the slope is -1/2. It is. So let me go back to the graph and demonstrate. So not only did you can go down 3 and over 6 and be at the next point, you can also go, watch, from A. You can go down 1 and over 2 and be at the next spot. Look at that. It's right there. Remember you told me, or you might have said, hey, Baron, how come you skipped and you went all the way over here? And you said, well, I saw another one really close. And I said, yeah, this will all work out in the end because these ratios are equivalent. This will work. And look, from here, I can go down another 1 and then over 2, and I'm right back on the line.